Okay, so we used our calculators to fill in the table. So just plug those into that. I don't know if you can see an orange highlighted equation over here. Okay, so if we go to the limit, to find the limit of theta as it approaches 0 from the left-hand side, so I'm going this way, what's y getting closer and closer to? 1. As I approach that 0 from the right-hand side, what is sine of theta over theta getting close to? 1. So what is the limit as theta approaches 0 of that?
1.
Very good. Lovely. That is super important. That idea. That you should memorize. Limit of theta approaches 0, sine of theta over 0, or theta is 1. Okay, so we're going to do it again this time. Only this time we're going to use 3 theta. So you would just do negative 0.01, store it as x. And when we type it in, we type sine of 3x, close parentheses, divided by parentheses 3x. I'll show you what that should look like. Here's what it looks like when you plug it in those last 2 lines. Okay, so you go ahead and fill in the rest of that information on that table.
What'd you do?
I broke it.
I didn't break it.
Yeah. I think I just slipped it out. I think it'll be okay. Yeah, maybe not. I think it's okay without it. It's hurting my ear anyway. If I'm going to fill in some numbers, you just start to disagree with me. Let's say something.
Oh, I know what I did wrong. Is it going to be...
Yeah. Technically, it's like 0.8. There's a 5 after it, which would round it up to a 9. But it doesn't really matter because what are all these approaching? 1. So as I approach from left, right, and then the whole thing is 1. So the whole point of that is that the limit as theta approaches 0 of the sine of any number in front of theta divided by the same thing is always going to be 1. Which is why I said in that last one, you just need to memorize that. Because if you try to plug in, and I think we did that last week, maybe not. If you try to plug in, you end up with the indeterminate form, 0 over 0. So this is just one of those trig identities that we can do with the table and figure it out. And now we've done it, so now you should just know it. Yep. Stick it in the head. This is going to be another one we're going to eventually just know. So same thing, when you plug it in the calculator, make sure you put parentheses around the top. You're going to store these numbers in as x's. I'm going to start putting in numbers. Yes, if it has an E to something, that means you move the decimal to the left, however many that number after E is. So that's where these are coming from. Good question. It's just the way your calculator does scientific notation.
I think I did something wrong. Calculator. See, instead of mine was exact, mine was forward.
Oh, really?
Yeah.
Yeah, that's the E.
Okay.
So when you move that decimal 4 places this way, you'd have 3 zeros in front of it. That's what's going on. I know, right?
Why can't it just go to like 10 or whatever?
I don't know. So as we approach 0 from the left-hand side, what happens? If I approach it this way, what are these numbers getting close to?
That's positive.
No, those are all negative, but they're approaching something. When you get more zeros after the decimal, is that number getting bigger or smaller?
Smaller.
So if you have a number that's negative and keeps getting smaller and smaller and smaller, what's it getting close to?
0.
0. If I go the other way.
0.
Yeah. And so therefore, the limit as theta approaches 0 of that is 0. That is something you should memorize. Because again, if we just plugged in 0, did direct substitution, we would get the indeterminate form. And there's really no easy way to simplify that. Alright, so on the bottom here, the rules then are the limit as theta approaches 0 of the sine of whatever constant times theta divided by that same constant divided by theta times theta, equals 1. And the limit as theta approaches 0 of 1 minus the cosine of whatever number times theta over constant times theta equals 0. Okay, so let's do some problems. So always the first bet is to try direct substitution. So plug in 0. You get e to the 0 times the cosine of 0 over 4. 1 times cosine of 0 is 1, you said?
Yep.
And you're using that calculator over there.
Oh, was that not?
Well, it might be a non-calculator problem, which I could see it. Anything to the 0 power is always 1.
Yep.
Cosine of 0 is that point, and so it's the x-coordinate, so that's where the 1 came from. So that's why your answer here is indeed 1/4. For now, you can use your calculator to double check it, but let's not depend on it. Unless it's a problem that specifically says, hey, you're going to need a calculator.
I'm happy we got a number.
This would be
Right? This would be what?
0.
Yeah.
Over 0.
On the bottom.
Okay, so this makes it look like it would be, except for the rule is limit theta approaches 0 of sine of c theta over what?
C theta.
C theta. What am I missing? A 4.
Four on bottom.
So if I just multiply, if I just throw a 4 here on bottom,
It'd be 1.
But you can't do that.
I can do that. I'm dividing by 4, right? I can divide by 4 as long as I also do what?
5 by 4 on top.
Or, which would be the same as multiplying by 4. If I divide and multiply by 4, then that's the same as multiplying by 1. So we just have to